and he was into the retina implant, for example, and that just fascinated me, like making people see again just with electronics. Wow.
On the Experts Connect podcast, we have thought provoking conversations with top performing experts on topics that matter to you. With Experts Connect, you'll uncover fascinating facts and gain the necessary skills you'll need to improve all aspects of your life. And how are you doing?
Hi, Katie. It's a pleasure to talk to you. I'm doing quite well.
Great. And can you please briefly tell us about your background?
Yeah, sure. Um, Back in my teens, I actually did quite terribly in school, so I failed school. But I had the chance to become a professional cabinet maker. So I spent the first 3 years of my professional life on construction sites, to be honest. And then I noticed it's not the way of life I intend for for the rest of my life. So I was able to start studying electrical engineering, luckily. And yeah, I focused on signal processing there, which was perfect because later in the studies, I noticed this is actually the most interesting field ever. So yeah, I stick with that. And at the beginning, actually, I focused mostly on healthcare applications. Also with my university in Trier, and there was Professor Koch. He was a really great mentor, actually, and he was into the retina implant, for example, and that just fascinated me, like making people see again just with electronics. Wow. And yeah, and so then I had the chance to finish my master's with Philips Research in Eindhoven, and that was actually on automated pneumonia detection. Pneumonia detection. That's a complicated word. So, and it was a really nice algorithm, but it was really classic signal processing, like wavelet analysis, etc. And but it was well conducted, really nice results actually. So they told me I should apply for a PhD position, and so I applied for a PhD with the Technical University Eindhoven,
Yeah.
Philips Research, and Maximum Medical Center. Yeah, exactly. So in Feldhofen, there was like a clinic, a hospital where we got patients. Then Philips Research as like the industrial partner, and TUE as a university. And that was really interesting because my topic was just fantastic. It was on preterm infant sleep analysis, or let's say automated preterm infant sleep analysis. And there I first, because I really quickly got to the borders of classic signal processing, and we noticed it's not working on preterm infant sleep. The topic was too difficult, and we said, like, okay, we have to try other methods. And then that was the first time I actually looked into machine learning, and then later also in deep learning. So now I like over 10 years experience in signal processing, and I would say in 2013 something I started with machine learning, and close up to that also was deep learning. Maybe later probably I explain a bit what's the difference here, but exactly. So it's quite similar, and luckily I came from signal processing, so that made the transition really easy. Yeah, and after I finished my PhD, due to my family reasons, I moved back to Germany, to Mainz. Beautiful city, actually. I could talk an hour about Mainz. You should come and visit. Um, so yeah, and it's really so yeah, and there I found a position, interestingly, at an electronic producer. It's called PHYTEC, and it's one of the hidden champions. Actually, they in the business, I think over 26, like around 30 years, and yeah, they're doing an amazing job at creating embedded devices for the industry. And you will find them actually in a lot of products you don't maybe know about, because we're never like the brand name in front, but we're mostly the electronics behind. And the interesting part is because they were not into AI at that time when I started there, let's say, at all. But our CTO, Bodo Huber, have to give a shout out here. He already saw, like, okay, this is a topic we have to somehow incorporate. And I, on the other hand, saw like, okay, there are a lot of companies out there, or like a lot of, let's say, a lot of people out there who can program AI, or create an AI solution, right? If you look worldwide, right? So if you have a problem, you could just hire somebody from Asia or somewhere, from Israel, and they will do a very good job. But I saw there was be a gap between the electronics and the AI, somebody who creates electronics for AI, because I just at that glimpse I had the idea it's okay, it's just started to transferring from the PC, from a classic desktop PC to embedded devices. That was just the beginning. I saw like, okay, we have to close this gap, and it worked actually quite well. It's perfect synergy. I learned again. I'm an electrical engineer, so I do know a bit about electronics, of course, but I still, yeah, I had a lot to catch up and learned a lot again. And on the other hand, I could bring a lot also to the company, just teaching AI and especially for our customers to teach them how to solve their problems using machine learning, artificial intelligence. Yeah.
Beautiful and inspiring career, Jan. I'm so
So far, yeah.
yes. So you're talking to us about machine learning today. So can you please tell us what exactly is machine learning?
Yeah, sure. Of course, it's a huge topic, and you could dissect it into classic machine learning and like deep learning. Maybe we can talk a bit later about a bit the wordings as well, when to use which words. But generally, you can see machine learning as statistical methods, algorithms to learn to recognize patterns. And the thing is, you don't do that by hand, but the machine will learn by examples. So they give them examples, and they start to learn and to understand from previous examples. Mm, maybe a good example would be or like to make a showcase would be the weather or something like that, right? So you could determined by hand, probably, like, okay, I want to see if it's raining tomorrow or not. So you can think of, okay, what's the weather today, where do I live actually, am I close to the sea, what's the pressure, what's the temperature, what's the time of year, like we call that features, right? So we can come up with that features and to understand that, and then you could program by hand. You could tap, okay, if the weather was nice and if it's July and if it hasn't rained for 3 days in a row, most likely it won't rain tomorrow, right? And you might have a good prediction there. But we know it got better over the years, right? And the thing is, here comes to play. The more complex it gets, the more difficult it is to do that by hand, and their machine learning comes into play. And the good thing is, you can just bundle up a lot of data, and you can actually bundle up also a lot of those features where you have maybe an idea of the problem, but there might be so many features that is nearly impossible to combine them and to see, okay, how they combine actually. So it could be like one feature, it's obvious, like, okay, this is a super good feature, but maybe another feature combined with two or three other features are even better than the one. And this combination you probably wouldn't see as a human, right? You maybe have the gut feeling, maybe that would be the gut feeling, right? You see, like, there's something else. I know it's raining tomorrow or something like that, but you can't really put it into to values, and that is a combination of those features. And as soon as you have that, and it's becoming more difficult than just, I don't know. I guess a super simple example would be, I measure my temperature. If it's over 37 degrees Celsius, I'm sick. If it's under, I'm fine. I mean, this is simple, right? I mean, you don't need any machine learning for that. But as soon, especially with the body, right, as a human body, as soon as you go a bit into depth and see, like, okay, well, I feel sick, but are there other indicators, for example, you very quickly come to a point where you have so many features and things which just interwork with each other that you cannot do that by hand.
Yeah.
And the thing is, so that's why the precision of the outcome just got more and more better. That's what I say, right? So the algorithms just got more sophisticated and more stable and got more reliable results with machine learning. And this idea of learning from previous data and creating this dependence on features, that is machine learning. Yeah,
I really
in
like
short.
how you explained it. Thank you.
Yeah, sure.
Yes. So, Jan, data science, machine learning, and artificial intelligence have been trending nowadays, right?
Yeah, that's true.
Yeah. So, can you explain if there are any differences with these terms?
Yeah. The thing is, mostly we talk about artificial intelligence, and this is an interesting wording because we have this kind of the huge bubble, which contains several other wordings, right? So artificial intelligence actually describes more or less everything, and it could incorporate much more than just machine learning, right? Also, just general computer science is part of that. Um, then machine learning is part of that. But machine learning, for example, has a subpart called deep learning. So deep learning is machine learning, but machine learning is not only deep learning. So it's kind of layered, right? I have a nice image for me to show that. So, if you look at that image here, um, you can see that you have different bubbles, right? And in the middle, you see this machine learning part, and here you see actually that's the deep learning in there, right? And you have the natural language processing is there a part of that, the cognitive computing, big data, etc. But it's part of artificial intelligence, but doesn't have to mean it's only artificial intelligence. So meaning there's a lot going on around these wordings. And artificial intelligence just describes the whole mechanic of you get some data, you pre-process your data, you're using some algorithm to understand your data better, to get some knowledge out of your data, and then use that to steer some processes, right? And that would be that's a kind of different. And then if you look a bit more in detail, so because especially we talk about machine learning with deep learning, what is here the difference, right? So that's why I before said there was classic machine learning and deep learning, for example. And the classic machine learning, even so deep learning is machine learning, we call it, but classic machine learning, it's a set of algorithms which are, let's say, a bit more simple is maybe the wrong term, but they were used for simpler problems, right? If you have less data, for example, if the problem is not that multi-layer structured, then it's very well to use machine learning. And actually, machine learning was like kind of before this classic machine learning just came up with algorithms. And at some point, people said, okay, we want to solve more complex problems, and then deep learning comes into role. The deep learning is something like these self-learning systems.
Yeah.
Well, people they misunderstand that quite a lot. Actually, I heard that quite a lot because people when I say or when somebody says self-learning system, they think like, oh, perfect. I put a camera with a system somewhere, it records something, and then it learns from that. So
Yeah.
that is actually not correct. Let's say you can program that, but that's completely different. That's a special topic. But let's say generally self-learning means here that the algorithm in itself learns to check and balance itself. So what it does, you feed it data, right? And as I said, they learn from previous examples. So I give them examples and I tell them, by the way, so now we want to look at cats and dogs. Um, so I tell them like, hey, this is a picture of a cat. This is a picture of a dog, right? And I tell him that. So, and then the algorithm learns. And now what is the self-learning part about that? And there's a difference also between machine learning and actually deep learning, because in um, deep learning, so we have the so-called back propagation, meaning we do a run through the whole system, right? And at the end, you just compare what the system thinks it detected. So like, oh, I think it's 70% probability it's a dog, but it's actually a cat. So it's like, no, 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 you are wrong. And then the system notes like, oh, okay, I'm wrong. So I have to start over, but I have to change all the parameters in this huge network. I have to change it to have better result at the end. And that is the self-learning part. So you don't have to actually tweak that by hand, and that you had to do actually beforehand with a classic machine learning, right? And this is actually gives you a huge headache. I don't know how many hours I spent in tweaking and parameter tuning. Dear
Me
Lord.
too.
Right? Oh my goodness, horrible. And this is kind of, I remember people told me like, hey, this the artificial intelligence when it first came out, the deep learning part, like this is cheating, right? So it's not reprogramming because you don't have to tune a lot of parameters. There are other things you have to do, so it's not no free lunch, right? But at least you don't have to tune those parameters, because this is like done over and over and over nowadays. Also for the classic machine learning, you have this part as well, like it's called auto machine learning. So it's getting a bit more automated here as well. But let's say back in the days, at least, this was the big divider here. But also other things, because one important part was one important difference between machine learning and deep learning is that in classic machine learning, you have to feature engineer, meaning you have to know about your problem, right? And as you said before, maybe my personal favorite topic, right? Preterm infant sleep analysis, right? So what we had back in the days, we had like ECG signals and breathing signals, and then you start creating to extract features from that. So meaning that you look, for example, at I don't know how stable is the signal, because if the baby is super deep sleep, the signal doesn't have a lot of noise, for example. So like, oh, interesting, noise is a good indicator. So if I have a lot of noise, most likely it's active sleep. If I have less noise, it's most likely deep sleep, and so on. And so you create a lot of those features, and just also like mathematical features, like a mean, I don't know, Fourier transform, etc. You can do all, whatever you comes to mind, you can do. But here you have to create these features. You have to think, how can I represent this problem and help my algorithm to understand this problem? And then if you have created these features, doesn't mean you're over, because then you have to actually do feature selection, right? Because if you just put a lot of bunch into like a classic machine learning algorithms, most likely it won't work good, because there are good features and then there are bad features, and the good one elevating the results, but the bad ones actually decreasing the performance here again. So then you have to do other steps in front of that. So you have to think, okay, which features might be good. There are actually systems how to do that, how to rank features, how to see which ones are important, which combinations are important, actually, which ones are redundant. So you try to get rid of redundant features, etc. So this is actually quite a lot of work, and you will never hit the sweet spot. You will always go slightly wrong, and you have to do that by hand and have to constantly keep all that in mind, and try not to go down the wrong route while you kick one feature out which was actually maybe really good, but you kind of messed up. So this kind of stuff. So in this process, a lot of things can happen, and here deep learning comes into play again, because that you don't have to do with deep learning. With deep learning, you kind of can feed it a raw data. Of course, let's say if you do have knowledge and do feed pre-processed data, it will work better. But let's say you don't have to, especially for this image solutions, which we see a lot, like facial recognition and this kind of stuff. Yeah, you don't have to do any feature selection, feature extraction, and this kind of stuff. So yeah, then maybe that's a huge difference here as well, right? A lot of manual labor which you have to put into classic machine learning, you don't have to put into deep learning here. Yeah. Yeah,
Yeah.
I would say that this is like the the basic difference here. Yeah.
Okay, so deep learning is easier then, in essence.
Uh, it's a good question. It's a different kind of art, right? Because still you still have to shoot for good results, right? And there's different ways how to tune your network, which network to choose, and the thing is, here you have to put a lot of effort into actually the data pre-processing, because deep learning networks need much more data than a classic machine learning network. So there more time is going into like the assembling of the data, getting data sets ready, annotating data. um I mean, again, going back to the idea of preterm infant sleep analysis, right? So we had to go to the hospital and collect data of infants. So horrible. I mean, go to a hospital, first of all, getting patient data, you'll get a headache for that alone. But then going to an ICU unit and saying, we need of the most fragile patient you have in your house, can we please have your data? And I don't know, mortality rate is really high. So dear parents, still, I mean, you have different things you had now, but could you please sign here to give the data of your baby? Very difficult. Takes a long time to get the data here. And there's a huge difference. If you do this with classic machine learning, you kind of, I don't know, you need just less. Maybe you can get better results with less data. And if you go with deep learning, Jesus, you might be have to collect much more data. So the effort is going more into data collection, annotation, and this kind of thing. So I won't say it's easier. It's just different kind of work. Yeah.
Okay, thank you for clarifying. And what tools do I need to know about if I wanted to start a career in classic machine learning or deep learning?
Oh yeah. So first of all, of course, as I said, if you come from an electrical engineering background, if you have signal processing as a background, perfect. You're done. No, but thing is, of course, back in my days, we mostly worked with MATLAB. Um, we started off with MATLAB, and I had to make the switch to Python. Nowadays, luckily, Python is a bit more not available, but broadly used. So Python, first of all, that is a tool to go. Actually, also, if you're in a Windows, working with Windows, I would highly recommend to change it to Linux just as a baseline, because it's much easier to implement. So to get started with Linux, it's much easier with all the machine learning stuff, because all the libraries it's much easier to do that. But then, of course, you choose one of the libraries you want to go for, um, as either TensorFlow or PyTorch. These are the two main libraries. There are others out there, MXNet, and I don't know, but like PyTorch and TensorFlow are the main libraries. You just choose one. Back in the days, let's say 2015, 16, there were huge differences between PyTorch and TensorFlow. This actually was in the latest version. You're just at the right time because now we have TensorFlow 2, and it's more or less kind of interchangeable. Even the code is really, really similar nowadays. So yeah, just choose one. Maybe the one with a bigger audience, not audience, peer group, and or maybe if your colleagues already chose one, you just go that route as well. So that we want, and then yeah, maybe make yourself familiar with also with one of the big data center services like Azure or AWS, because of course you can run stuff on your laptop even like a basic classic machine learning algorithm. You can do that on your laptop, but let's say I wouldn't recommend because you have to iterate a lot,
Yeah.
and yeah, it's nice if it's going a bit faster. Then you just the development process is a bit faster. You see your errors, you can quickly iterate with the errors, and you get better results a bit faster. So yeah, so go for one of those. Um, yeah, that's of course, and the thing is just one. It's a classic machine learning. You should not forget about that because a lot of people think now that, oh yeah, it's all deep learning now. True, it's more, let's say, it's maybe a bit more trendy deep learning, but machine learning definitely has its place. And especially, as I said before, if you have less data, uh, classic machine learning algorithms can and will most often outperform deep learning networks
Yeah.
up to a certain point. I mean, deep learning networks really scale well with a lot of data. So, meaning, if you know you will get more data, you can also start with deep learning actually, because the more data you get, the better the model will get. And this is not the case with classic machine learning. That will kind of stagnate at some point. But if you have less data, first go with classic machine learning. Also, if you're thinking of later computation power, I mean, I'm coming from the embedded world now, right? So if
Yeah.
you're thinking of putting something on an embedded device, yeah, just the raw calculation power is needed for running a deep learning network, not training, just running, um, is also hugely different between classic machine learning and deep learning models. So if you have that in mind, you need a really small device, maybe battery operated, something like that, like a classic machine learning algorithm might be actually more suitable than a deep learning. So don't disregard machine learning at all. And if you want to also look into machine learning, that's actually the one library is scikit-learn is called. That's the library for classic machine learning. While you actually can do it also with TensorFlow, I think, but yeah, I would stick with the classics. um, yeah, I'll just check. Maybe I have a short list here somewhere. Um, so I think you see that now, right? Do you see my cursor?
Yes, I do.
I do the laser pointer. So as I said before, right? So we have here like PyTorch, as I said, we have here TensorFlow, MXNet is another. This is a platform for that, and then we have here the AWS, Azure, Colab, Kaggle. These are all platforms where you can run your models actually on more sophisticated machines, run a bit faster. Right, and then tools to just work with the code are Spider, Jupyter Notebook, and Visual Studio Code. The three here, just choose one of them. They're also okay. To be honest, they are different actually. So Spider and Visual Studio Code are relatively similar. While I personally like Spider very well, actually, it's really well to just develop your code, but for integration into larger systems, Visual Studio Code is a bit more handy because you can better integrate stuff. But just for sharing, to quickly try stuff out and just to share with your colleagues, Jupyter Notebook is really nice because you can have really nice also descriptions of your code. You can put in graphics, etc., and you can actually just run small parts of your code to see if they're working. So they all have their benefits and their negative side, not, but like their downsides a bit maybe. So
Yeah.
just again here, just choose one and see where you best fit. And I think over time you anyhow will end up using all of them at some point. So I always kind of switch between, and depending on the project, with larger projects I go with for Spider, for smaller ones I go with Jupyter Notebook just to try stuff out. And yeah, and I just also switch between Visual Studio Code and Spider. Maybe not the best way actually. Maybe you should stick to one, but yeah, that's it. So yeah, and on the side you see all the tools as well. So I just listed them a bit. This are just the machine learning libraries.
Mm-hmm.
Here are the tools to work with, and here actually the cloud services.
Wow.
Um, while actually Colab should be down here. Sorry, Colab is
Mm-hmm.
from Google, actually, also a platform from Google. It's kind of in between. Okay,